In section 3.2, our goal is to find results using perpendicular lines. We're also going to talk about types of proofs. Once we write down these theorems, we will be drawing pictures to go with them. Now remember that postulates, when we write those are the ones we accept without proof. Most of the time they kind of sound like common sense, and we just accept those. We use them. Theorems are things that can be proven, usually using the postulates. We can actually do a two-column proof and prove that a theorem is really true. The postulates are just numbered in the order they appear in the book. Same thing with the theorems. So the first one is theorem 3.1. That means we're in chapter 3, and this is the first theorem that we've discussed in the chapter. There is no reason to memorize the numbers. You do need to know the content of the theorems. So theorem 3.1 says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Please pause and write this down. We're going to move on to the picture. So we have two lines that intersect, and when they intersect, they form a linear pair. Okay, so they're going to make a line. A linear pair of congruent angles. So I'm going to have this angle and this angle be exactly the same, those single arcs. The only way that's going to happen where your angles add up to 180 but they're exactly the same is if they're both right angles. But if our two lines intersect to form 90 degrees, then they must be perpendicular. So if that's true, then line L would be perpendicular, upside down capital T, to line M. Theorem 3.2. If two sides of two adjacent acute angles are perpendicular, then the two angles are complementary. Please pause. We're going to move on to the picture. So two sides of two adjacent acute angles. Remember, adjacent angles share a common vertex and a common side. So I'm going to make this my common side. Here's my vertex. Now the other two sides of these angles, and they have to be acute, so less than 90, are perpendicular. So if those two sides are perpendicular, here's the first one, and it needs to come down and form a right angle. They're perpendicular. They're 90 or they're a right angle. Then what happens is these two angles must be complementary. Since this is a right angle, we know it's 90 degrees. Two angles together adding up to 90 must be complementary. Remember, complementary is the one we can make 90 out of. Theorem 3.3, if two lines are perpendicular, then they intersect to form four right angles. Pause and write this down. We're moving on to the picture. If two lines are perpendicular, first line, second line, I know they form a right angle. However, we talked about vertical angles. So if this is a 90-degree right angle, vertical to this is 90 degrees right angle. Also, our lines add up to 180, so 180 minus 90 means this is 90. Vertical to that, this one's 90. So anytime you have perpendicular lines, they actually form four right angles. There are three types of proofs we'll be discussing. The two-column proof is the one we've been using, that we use to prove statements about lines, segments, and angles. So the two-column proof is the most formal type. It lists the numbered statements in the left column with matching reasons in the right column. And we did say that you have to have your statements in the left, you have to have your reasons in the right, and they do need to be numbered. This is the one we'll use the most in class. There's a second type of proof called a paragraph proof. It's exactly what it sounds like. You put the proof into a paragraph using complete sentences, and it's more conversational. It's like someone saying that they were absent from class, and so you're explaining the proof to them. Whole sentences, whole thoughts. Each sentence incorporates a statement and a reason somewhere in the wording. The third type is called a flow proof. This uses statements and reasons, but the logical flow connecting the statements, instead of going down the list like a two-column to the logic from one statement to the next, this actually uses arrows. So what happens, and I'll show you this during class, what happens is my statements are inside boxes with the reasons outside, and if you use this statement to get a new one, there's an arrow to show the flow of logic. We'll work through a proof in class with two-column, paragraph, and flow. And then we'll be working on book page 138 to 141, number 5 through 9, 11 to 16, number 26, 27, and 29 through 36.